everyone. So we decided to create a live stream just to talk to you guys about our product, show you some features, how to use it, how to work with it, how to contribute code to it, how to implement it, how to use the open source version, and just meet the audience and understand what you guys like, what you want to see in the next few versions. Thank you, AJ. He's one of our contributors, and he pretty much did most of the front end for us. So let's wait a few more minutes, and then I will start talking about and showing you the live version, the live demo, how it works, and just maybe upload the document to and show what the difference is between the models and how they can be used.
How are you, AJ? How is it going? Or how are you guys in general? Maybe tell us something in the chat while we're waiting for more viewers.
At the end of the session, we can actually invite people on the stream. So if anybody wants to join at the Q&A session at the end, which will start in like 30 minutes.
We also have a small delay for some reason on the translation. I mean, on the stream. So if we're a bit late with answers, sorry, guys. Nice.
I remember you told me we were showing it to some people. Did you show them already the product? Or are you gonna still show them tomorrow, AJ? Right, I think I can entertain you guys a bit more and show you the demo, how it works, and show you a few features of the product. And I need to start streaming my screen first. Okay, turn off the video. Just this layout. Stream. Oh, sorry, file.
Nice.
Trying to figure out. Okay, now let's add file to the stream. Okay, perfect. So in terms of the product, what we've been working on recently and what we have added, one of the things that we added for the Pro plan is the GPT-4 modules. And there are some minor differences between them, but mostly they come to how many documents do they ingest every single time that they parse something. So the fast module, it starts with just 2 documents, and it's ingested at the same time. So the response time is usually much faster. So let's try just this PDF document and also some rise this paper. What's it supposed to do? It's supposed to summarize the documents that it finds in the paper and give me a nice concise summary of it. It's a bit longer than the previous module, like the GPT 3.51, which uses the ChatGPT behind it, because GPT-4 does take much longer to feed in the documents and provide the response. But at the same time, the reasoning and the quality of a response is better and more structured, and it's larger in general. Like just with GPT 3.5, responses are usually made to be concise and short, but GPT-4 responses are made to be much longer and larger. And this is probably the reason why it performs so well, is because responses are much larger. So we summarize the paper here.
Hello, Zombie.
we summarize the paper with the GPT-4 model like this, and we can try and see how well will 3.5 deal with this task. Response should be quicker. We shouldn't be waiting like 20, 30 seconds like we wait with GPT-4 models. So it only took, less than 10 seconds maybe to respond right now. But also the description is not as large. And many of the references that it is making is actually making to the source document. So it's more like providing the same text, the same response. And let's go to a more fun one, which is balanced one. Summarize this paper. All of the requests that are running behind, they're all asynchronous. So that means that pretty much in the ingestion stage, everything is parallelized, and it doesn't have to wait for previous stage to finish. But there are two main stages that we have. First one is when model cuts down the source material and brings up the relevant parts. And then the second part is when we use the relevant context, and based on that context, we provide the answer. So this should be the most cohesive one. So this paper introduces transformer, a novel neural sequence transduction model that relies solely on self-attention. So as you see, this response is the most different one to others and probably has more context than others. And at the same time, it regurgitates information in a more processed way. But in general, if you have any simple questions, like, for example, on our documentation, right, DocsGPT, we can just ask it, create mock API request for API response answer with Python, right? So there won't be as much difference between the first model and the GPT-4 model, because the answer is quite simple in both cases. But if your use case is more complicated and you're working with science material or anything like that, I think it's much better to use the GPT-4 model, because it's going to be way more complicated. Also, for this project, right, we allow users to upload around 10 documents for free, and you can upload anything you want pretty much, and there's a search button here. But the big advantage of it is because when you upload the documents, usually use OpenAI's embeddings, which are expensive. So if you go and search OpenAI embeddings pricing, right? And for example, for simple documentation, something like Python, you will run up into a few dollars. It will cost you a few dollars. So although it's $0.0004 per 1,000 tokens, right? Something that is 1 million tokens. So 1 million tokens multiplied by 0.004. Okay, maybe I mistaked some numbers. No, I didn't. So sometimes the price is too big for large documentations. So what we actually use here is we're using Hugging Face embeddings. We're using this model, and it's very convenient for us because we run it on our own hardware, and we're paying much smaller price than we would have paid otherwise by using embeddings from OpenAI. And in our open source version, if you want to switch from one type of embedding to another one, we'll show you today how to do that. It's not very hard to do. So here's our first response for how to create a mock API request for API answer, which is totally correct. So prints what we need. And let's just, for fun, ask the GPT 3.4 how to create API request for API answer in Python. The response here should be pretty much the same. So there isn't much difference for simple requests between the models, but the more complicated your requests are, the more you're going to get out from the pro feature. And at the same time, responses are relatively quick, as you can see here. So let's try and upload something. So I have this file that I like to use. This is just a paper on the transformers, on the architecture and idea behind all of those GPT models. Takes around 10 seconds to train and ingest everything. So it's done. We can switch to it now in our source docs menu and ask the same question I was asking, like summarize this paper. And next question we can ask it is describe the architecture. Describe architecture of and also, if you guys like the response and think it's good, just leave an upvote because we will use this data and we will make a better model in the future that will actually take all of your feedbacks in account. Because at the end of the day, a better model really does come down to having a lot more responses and having better data that you can use to build a better model on top of. So although it's the normal ChatGPT one, it gave a very concise answer and relatively quickly on top of the paper that we provided. So just for fun, let's try and ask our more complicated AI the same question, like describe the architecture of transformers, and see how different the responses will be.
Also, regarding ingestions, we are happy to hear your suggestions, guys, of what other file formats, maybe what other languages you want us to try to introduce, both for the website version and self-hosted version. Additionally, I think we plan to go through how we do code ingestions later in the stream. So maybe if some of you know some other languages besides Java, JS, and Python and want to help us create simple ingester, we'll be very happy.
Currently, there is a bit of a limitation with the JavaScript ingester because it does take pure JavaScript. And if you use something like JSX or TypeScript in it, it will not actually parse it that well. But the idea behind parsing is very simple. And once we get to that part, I'll show you how it all works and how to parse data and how to make sure that it actually parses it well. So as you see, this one gave us response just within 10 seconds. But the bigger the model, the more coherent, the more it thinks about, right? The more reasoning it takes to answer the question. So here is the two different answers. And as you see, right, the GPT-4 one gave us much more structured answer. And yeah, I think if I was trying to learn and summarize the paper and ask it questions, I think this is probably the one that would give me, the best quality response that will let me learn the quickest. So next thing we can touch up on is our GitHub. I can show you the repository. So the whole project is open source. This whole thing is running in cloud, and you can run every single thing the same way it is running here on your own computer locally. So unlike other projects, we're fully open source, and you can check all of the source code here. So just as a quick introduction to our repository, here's a quick guide how to start it. We use a thing called Docker because it's very convenient to start everything. We have 5 different containers when we launch the application. So first container is our application on the backend. The second container is the front end. Then we have the worker. Those are our background workers that actually do all of the embeddings. So whenever we upload documents here, it will go to our background workers, and they will have to handle the embeddings, because we can't wait that long on a single web request. Sometimes it takes 10 seconds, and if you're uploading something very large, it can take even an hour. And then we have Redis. This is what we use for as a layer of communication between backend and worker, so we can store the tasks. And then Mongo, we use it as a database. So later on, you can understand where your files are and how to find them, how to get them. And if you're trying to launch this project, you will obviously launch container from the front-end folder and 2 containers from application folder. We also have other folders in our project, which is scripts. Here we have our ingestion CLI. You can read about it in our wiki under the how to train on other documentation section. It's a nice CLI. Why would you sometimes want to use CLI is because by default, the web version, it supports RST, MD, PDF, TXT formats, but it doesn't support Microsoft Docs, CSV, EPUB, and HTML, but you can ingest all of those formats via the CLI. And it also has more rules that you can use here to make sure that your ingestion is more comprehensive. And then it also checks the price of tokens, because just like I mentioned earlier, every embedding costs money. And if you want to make sure that you don't run into some unexpected expenses, you can always check the price. It will ask you for user response if you want to skip it or not skip it. Yeah. And then you can also manually alter the amount of tokens that are ingested in each chunk. So let me open our application and go to let's go to scripts inputs and see what I was ingesting. So for example, this is our documentation, and this is our README, right? What will application do is it will take pieces of text, and it will split it based on amount of characters, based on tokens, right? Because at a single time, model can only ingest either 2,000 or 4,000 characters, tokens, and it's important to make sure you don't overgo the limits, go over them. And we will basically chunk the files and ingest depending on the limits that you provide here in our CLI. So you can either make sure that the minimum amount of tokens is higher. That means every single time you make a request, there will be more context provided to the model. But if you set, for example, max tokens lower, you make sure that you chunk it in smaller pieces. That's essentially the idea. And here we have another part of our CLI, which is a convert function. So it allows us to convert source code to to documentation basically, and then use that documentation to feed it in our model. So you'll basically be able to, talk to your code, essentially document your code and talk to it inside the application. So has anybody tried our CLI? Has anybody ran into troubles when they were ingesting it? Because I remember we had a lot
I want to add that
that
some functions even in the CLI are not included because it will make it too chunky. So if you are struggling with some of the ingests, for example, you want some other properties like to keep the links or something like that, many of those properties are already in the code. You just go to the corresponding file, for example, RST parser, and it probably will be there because there are many rules for each of the parser. For example, RST removes links. Then it tries to remove like table formatting and stuff like that to make the response more concise and more semantic as possible. But if it somehow affects some of your documents in a negative way, just go to the corresponding parser and you can change it to your liking.
Absolutely. Okay, I think I can show you guys a quick demo on how to start the application, how to host it, how to ingest set documents, and how to ingest code at the end of the day. So we had some people having troubles with Docker and things like this, but it's a very convenient piece of technology because basically all you need to do when you start with a project, first you clone the project, open it in your code editor. I use PyCharm because most of the code here is in Python. It's quite convenient for me. So first we want to build our containers. So what it will do is we'll take our Docker Compose file and it will find those containers here and it will basically build them and it will allow us to launch them later. So all we do is Docker Compose build. On your first run, it might take a minute or two, might even take 3 minutes to build the containers because I've been running it before. It's using cache and it's being much faster. And now I launch it, Docker Compose app. So it will take all of the containers that are in our Docker Compose file, and it will launch them. And you can go and check the services and see what's being launched and what's working. We can go to our Docker, let's say, and just quickly launch the dashboard and check the containers. So as you see, we have 5 containers here. The front end, the back end, the worker, Mongo, and Redis, right? And all you need to do is to go to this one, to the link here. 5173. And that's it. That's our application, the same application we have here. You can chat with the models and hi type. Okay. Not happy with me today. The file is not there. One second. So what happened here is because the file, it uses the indexes. The indexes were not loaded, and I already had them selected in my UI. And if this ever happens, just reselect your indexes and it will work. And your indexes are stored here in this application indexes folder. And this is the name. And you also have the Docs Hub indexes, which are basically public indexes. And you can find them in these folders as well. So every single time you start this application, it comes with preloaded indexes that come from our Docs Hub. But if you want to upload your own, which is probably the main purpose for you. You can, again, use the UI to upload it. We'll wait a few seconds. Look, it's embedding. It's done. Click finished. Let's summarize this paper. We ask the same question we've been asking our hosted model here, and it will give us a similar answer. Yep. And you can also leave feedback. It will also go to our servers, so we can, make sure the product is better. And the paper we uploaded is here. So, for example, if I change the name, I upload the same thing, right? I just change the name and I say document one, right? It will go into our folder here. So you see the folder is created now, and those are our index files. And if we switch in source docs, if we switch in the menu, it will choose the documentation from this folder and this location. Okay, let's go to the next part and try ingesting source code. So to do that, we need to go to scripts folder. You need to make sure that you have a lot of dependencies installed. I even have a separate Anaconda for this, because it does require a lot of different dependencies to make it work. And the primary reason for this is because when it ingests code, it uses different parsers from different languages, because we have Python, JavaScript, Java, and in addition to this, we have Sphinx parser for just normal text, and that takes a lot of space too. So to run our CLI, which I have not run in a while, you need to write Python ingest py, Python ingest py, convert.
Just
convert, yeah. Convert, yeah. And I don't think I need to mention, I only need to mention formats. But if it's Python, I don't need to mention it because default is Python. Then let's convert our application.py file just for fun, and see if it can answer any meaningful questions based on this source code. So all we do is we put our code or documents into the inputs folder in scripts. And then once we're in scripts, make sure you have the right location. You write Python ingest py.convert. And it will basically take our file and it will break it up into small chunks. Okay, I don't have this module. Pip install. Okay. Maybe I have the wrong Anaconda for this. Okay.
I think it's premise for GS, but still required.
Pip install R requirements. So before you launch it, make sure you run this line pip install R requirements.txt. That will install all dependencies inside the scripts folder, because dependencies here are different from the dependencies in our application. And the main reason is size. Let's try compare it to another file. Application input scripts. Yeah. Yeah, let's compare it like this. Okay, so as you see, it's a lot more additions here, other than it would have been. So we have a Prisma, utils, all of those things, image size, Java lang, manifest as well. Maybe some of them are not necessary, but that's good for when we're experimenting with things. Okay, let's ingest now. Python ingest.py convert, and convert the code to documentation, and then use the documentation to create vectors. And then it will use those vectors to generate answers on your questions.
The way Python 1 works, it firstly creates the list of all functions used in that code. And while sending it to OpenAI, it creates sort of documentation for each of the function. And then it creates a list of classes which with functions, with each function which class it depends to, or if it doesn't, it doesn't. And then creates with already previous knowledge with that self-created documentation for each function. It creates documentation for classes also. And then using that, it can answer questions, basically.
So it already generated some text. And now it asks me if I'm okay with the price. So it's 7 cents to ingest it. It's approximate price. It's not extremely precise for conversion, but for ingestion it's much more precise. So it's processing. It's going to tell you when it's processing each file, and it's going to tell you when it's processing each function. So you can nicely track the progress. We also have this pro version, and at the end of the stream, we will give you some nice promo codes with a 50% discount that will work today. Okay, done. So it processed all of the functions inside our source code. And so as you see, it generated this output. And inside this output, we have this markdown structure. It's a markdown document, and it basically generates heading, which is a function name. Then it gives us the function itself. And then it creates mock documentation here. So this function runs a synchronous chains of functions. It takes in chain of functions a question, a chat history as parameters, and then creates new event loop and sets the current event loop. So basically, this is the function that makes our requests asynchronous. And then there are other functions like ingest function, tells us what parameters it needs, what it returns. Then, for example, the most interesting function is API answer. Takes a lot of context, right? And then it tells us that this function is used to answer a question using API. It takes in JSON object containing question, history, API key, embedding key, and all other. It uses these two parameters to access appropriate API, and then checks active docs, loads the index store and prompt template based on embeddings choice, and then it creates a prompt template based on history. So it's a very thorough and good description of what each function does. So essentially, it generates documentation for us. And all we have to do now is to run Python ingest.py ingest.
And you need to transfer it to inputs first.
Yeah, you need to transfer it to inputs first. Yeah. It's also important to make sure that the documentation that it did generate was okay for you, and if there's anything you want to cut out from it, or you want to repurpose this documentation in future. Okay, it tells us the price because it's so few tokens. It's pretty much less than 1p. Okay, generated our index files. all you have to do now is copy them and move them to the root location of our application. So you see those two index files we have here, we basically have to replace them. And we can easily overwrite, and that's it. They're now changed, they're now different. Now we don't need to restart the front end. All we have to do is to go to the default option and ask it a relevant question. So for example, okay, what does download file function do? And at the same time, we can prepare a different question for API answer, right? And when we're building API or connecting,
which parameters does it take?
Okay, yeah, good question. So most program for individual download function without context or information regarding where.
Are you sure that it got injected in front end?
Yes, you don't need to restart it usually.
You can drag it as file just to make sure.
Yeah. Okay. Let's make sure that I did. Okay.
No, I meant you can drag appmd.
Oh no. Okay, I'll try copy paste it again. Okay. Right. All right. Does download file function do? Maybe so once we have cases like this, and for example, we don't know why it's not working, there are a few things we can do. What parameters does API take? So for example, if you're debugging the application and if you're trying to make sure that you get the source documents, I think it's this function you have to alter. Let's try and change this function a bit. Why is it not loading for me? Okay. Factor generate opening. Okay. I know why. It's ridiculous because number one, we're running it in containers, right? So when we're running all of our code in containers, it's not always linked to the file system that we have here. I think what we do have linked is, so basically we have to rebuild our containers. So after we ingested the new documentation, what we have to do is to rebuild them. Build, no, cache. There's another way we could have ingested it actually, is if we copy this file, copy this documentation, and let's say we just ingest it here. So we have our appmd file. We go to our web application. We choose the appmd file. Finished. Appmd. What does what parameters does API answer? take. So it's currently in the process of building. It might take a minute or two for it to finish. Does take a JSON object containing question, history, API key, embedding key, active docs, and embedding choice. So I'm going to show you how to actually make it work on your local version. You basically have to rebuild the containers because depending on how you set up your Docker Compose file, I don't want to show it on live stream because I have my keys connected to it. But basically, we have our Docker Compose file, and as you see, our application, right? It syncs few folders between container system and your local system, and those are inputs folder, indexes folder, and vectors. But it does not sync the two files in a root. So you have to rebuild your containers if you change any of the files here. I think we'll publish this video so people later on can understand how to, go through this process quicker and easier. I could have just put them in an input folder. Yeah, that's just instead of, for example, document one, and that would have actually synced it with the container because those sync with the local and container systems. But nevertheless, in case you wanted to change the default one, this is how you do it. And this is why it may have been not working for you before. Okay, so we have all of the containers up and ready. Let's go back to our function and what parameters does
answer something. Okay.
Yeah, API answer function take. However, based on common conventions, so I don't know what's still going wrong with this one, to be honest. Let's try to substitute the document one files. Copy. Paste. I'm just afraid that Docker, sometimes it uses the cache and sometimes it might not do what we want it to do. Let's try it this way. Now it did give us the right answer. So given the context, requesting fast request to JSON, the method access following parameters within the JSON object, question, history, API key, embeddings, key, active docs, and embeddings choice. This is basically all of the things that it needs, right, when it makes the request. So we have this answer request that is made in the background, and as you can see here, payload, it gives it active docs, API key, embeddings key, history, and the question. Right. And if you want to, for example, contribute to the project, my suggestion is when you're working either on backend, you're working on front end, just remove those pieces from your Docker Compose file, launch all of the other services, and for example, if you want to work on front end, just go to your front end folder. Run npm install, and then run npm run dev. And this will launch pure front end in your desktop. And if you make any changes in the source code, you'll be able to see them being reflected immediately. So if I want to change anything in SRC, let's say I want to change the hero message, right? So for example, you're launching something else, I don't know, DocsGPT v3, I don't know. And that's it. And it's going to be reflected straight away, and you don't have to rebuild your containers and do anything to reflect the changes. And if you want to do it with the application, it's the same route. Just make sure you remove the backend here and just launch it with this command, python app.py, and you'll be able to, alter the application on the fly. We also have extensions. We have 3 extensions right now: Discord bot, Chrome extension, and a Chatroot extension. All of them work, and some are quite simple because they basically create this loop between between the front end and back end, where they only send answers and they get the responses. So because there's no uploading, there's no tracking the task status, all it really needs is to fetch an answer by creating this simple post request, and it will get the response and it will send it back to the chat. So currently in our Discord, we do have a bot that will answer your questions based on our documentation, and you'll be able to chat with it quite nicely. And it will actually provide you relatively good support, maybe better support than I will in some cases. So finally, wanted to do the quick question answers. What do you guys think? What questions do you have? What use cases do you have for the bot? We had some people who wanted to do chatbots on support documentation, so something that they can integrate into a website. So like a chatbot on a website, but with the functionality to provide support. So anything you can ask questions, anything you can chat with, because it is very convenient. It does provide a lot of.
Glad to hear that, Sam. Also, hello. Good that it's resolved now.
First of all, hello. First of all, it's very good. Running it locally. At first, I faced token issue. After a while, Alex solved it. Yeah, we had a token issue, and the reason for this token issue was very simple. Is because there are 2 types of ingestions that we have. First one is just do one single API call with everything at the same time. And then there's a MapReduce one, which basically takes every single request, every single piece of document, summarizes it, and then uses those summaries that are relevant to your question and creates a final call with the large language model where it has all of those small summaries that are relevant to the question, and using them, it provides the answer.
I think for the new problem, it's better if we can talk in Discord, maybe, because we have to do some testing to try to help.
You know what? Maybe it's actually the same issue that I had right now on the live stream, because you do need to rebuild your containers after you paste them to the app folder. because the container, the worker, it only synchronizes the index folder, the vectors folder, but it doesn't synchronize the root folder. So you may need to rebuild your containers, do something like Docker compose build //no/cache and hit run on it. And I think that will resolve your issue, Thailand. Even if we try to host it using different virtual machine, in the HTML console, it returns cannot fetch JSON. Any ideas on how to resolve this? Yeah, I think this question we can move and discuss it after the live stream, because I think that's very specific. Any ideas? Cannot fetch JSON. I mean, it could be the reason is probably the routing. So it's one of the two. You can check the logs. So if you have issues, just check your Docker logs, find what the error is. And if there's no error, and it's just error that happens in your front end, then it's probably connectivity issues. Probably your front end can't find your back end. Can you explain in a simple way how LangChain works with DocsGPT? So what DocsGPT uses is the way we work with the indexes, right? So when we need to ingest our data, when we need to upload our data, we create an index. Basically, what index is like a search algorithm. It's like a semantic search algorithm. So if the words are similar, it would find something that's similar. And this search algorithm is built upon FAIS, which is Facebook's library to store vectors. And LangChain has a nice wrapper on top of it to store the data and to retrieve the data from that vector store. And additionally, we use LangChain as a wrapper on top of OpenAI's API, because it is convenient for our use case. But in future,
not only OpenAI, to be honest.
Yeah,
you can use it with Hugging Face already, and we do it with embeddings on the live version on our site, and many other LLMs. Like you can connect Llama with it and stuff like that.
Not LangChain. You can't connect LangChain with Llama right now. You'll have to write a custom wrapper for this, but it's not very hard. It's only 2 API calls that you need to make, or 3, depending on how many documents you want to parse. But Llama is a very interesting piece of technology, because I think in future, things like this will run on smaller and smaller devices. You can already launch Llama on your, on my MacBook, and it will run there very well. And because of it, we can easily query and get relatively good answers from it, just because it's in in such a small package. Is very convenient.
We'll try to help you after the stream if you still have the problem. Same.
Finally, I wanted to show you our roadmap.
Jay has a question as well. For data-sensitive firms, how do they wire other LLMs with DocsGPT?
That's a very good question, and this is something we're working very hard on. We already have a few companies that do work with a lot of sensitive data, and we're preparing. We've showed some small demos that use the models like Alpaca, models like Stanford Alpaca, if you heard about it. What's important here is that if firms are working with sensitive data, and if they have a strict on-premises rule, that means you cannot use OpenAI. That means you cannot use Cohere or any other company that provides large language models. You have to host those large language models on premises. And there are a few options that are available. Number one, it's Bloom models. They're very large. They take about 240 gigs of VRAM, which is pretty much a tiny, data center full of GPUs, and it costs a lot of money to run. But there are smaller models like GPT Neo X, and the most recent one, which is Stanford Alpaca, which you can even run without a GPU. You just need enough memory on your device. So if data sensitive firms want to run it on premises, they need to choose LLMs that they can host on premises. And right now we're also working on building our own LLM. We're fine-tuning basically Stanford Alpaca LLM. We're trying to fine-tune some other LLMs and to make sure that the quality of responses is as good or better than ChatGPT and GPT-4's ones, specifically for our use case. Because our use case is still slightly different to main use case of ChatGPT or GPT-4. It's not this generalistic use case, right? Our use case is working with documents and providing answers depending on those documents. So I think if organizations also take a simple standard Alpaca model and just fine tune it continuously and have enough people in their company use it, they can, after building a good enough data set, fine tune it and have really nice responses as well.
It is also important to say in which way, I guess, the data is sensitive. Like, are you not allowed to show it to the rest of the world apart from the company, or maybe like some people inside of the company? So you need for that. I guess you just build more indexes for different files and create indexes without, with the use of whitelist and stuff like that. But yeah, the biggest problem now for the custom use is model hallucination, because it starts saying something which is not correct, not true sometimes. So each time you leave dislike near the answer, it helps us a lot, because it helps us retrain the model, both of them.
Exactly. And the biggest issue is hallucination. So, and the way to solve hallucination is good feedback. It needs to learn and train more. And for our use case, what's also nice is when you're using it generally, right, and you're asking questions about legal system or anything like this, it will sort of try to pull from its memory, but there's no way to verify that the memory that the model has of the past events is, correct one. So it's hard to fine tune on those details, but it's much easier to fine tune on use case like ours, because within the prompt, we provide the context and the model only needs to answer on top of the context provided. So in the case of hallucination, I think it's hard to solve the problems for any model, but it's much easier to solve it for models that already use the context for the answer.
Thank you for your questions, AJ. Good, keeping up the stream live. So what should we move forward to, what we plan in the future? And then
I think so. I think that's the right way. We have some plans. We have some big plans into the future, and I think it's important to structure them and prioritize things. We have a nice roadmap that everyone can access. It's on our GitHub. I'll show my screen again. This is our roadmap. To access it, all you need to do is just go to our GitHub, click projects, and then click DocsGPT roadmap. So we have all of the issues that you guys have submitted from the repository. and we can put them here and prioritize which issues you want to be solved next. So this is all of the issues we already solved, and those are the issues we're planning to solve. So we're currently working on using remote stores. So we will soon be able to upload the data straight from the website, straight from other sources of information. Another thing you guys been asking a lot for is citing the sources, because it is important to another issue with citing the sources. And we can cite the sources, we can cite the information. It's mostly just adding it in the UI and making sure it does look nice and it doesn't make the interface look horrible. Because sometimes when you will open those sources, you will have a lot of text, you will have a lot of material, and we want to make sure that it just looks nice and coherent within the UI as well. And we have some bugs to solve as well, to be honest. And then for to do, we have Open API Swagger parsing, basically taking and ingesting data from just API documentation. Because if you do want to ask questions on top of source of data like API, it's much easier to do it when you have DocsGPT at your hand, because you don't need to read through all of it to understand it. You can just go straight to the solution that you need. Multiple charts for different sources of documentation. I was thinking about it, and personally, I have few thoughts about it. I think if Nick is watching this live stream, I don't know what his opinion about it is, but so we have this chat button here, right? And we think to use the space a bit more. Personally, I've been finding myself using this space a lot more in general. Like, this is my second most important area. This is the first most important area because I read all of the text here, but the second most important area is the source docs. And I was thinking maybe we should move it up and leave like top source docs as options, and then like a little search bar to alter between them. I don't know, but I think, yeah, if we separate the source docs here somehow and use this area to answer the questions on top of them, that'd be very convenient. That would probably be nice. What do you think, Pavel? How would you want to use this space?
I think chat history would be nice, personally, but
Just
that will
chat
be
history.
a big feature.
Probably would be, because you do need to store the data in Mongo.
Yeah.
It's not too complicated, but yeah, I think it's about storing the data uniquely.
Additionally, from big features, what already Alex talked about, and I said a bit, is that we're working on our own LLM based on Alpaca for now, but maybe we'll decide to switch later. That probably will be a very big function from my perspective, at least, because you won't be spending credits sending it to OpenAI, and
privacy,
I think at least at the beginning, we'll make it available on the site, and I guess we'll make the code open to it as well. Additionally, what I'm looking forward to is building indexes, so editing them, maybe adding other information to already built index.
We had this issue here.
Yeah.
Add delete to from existing vector store.
That will make it possible to upload your full stack, for example, for your app or something like that, and thus answer a question about all of it at once. So Docs will know all of the libraries that are available to you and how to combine them, essentially. Well, about the combining them, probably a bit harder for it, but it will at least know all the libraries you're working with and answer questions all at once.
Absolutely.
So guys, do you have any other questions? Maybe. Yeah, Alex, what you wanted to say?
I do think that deleting documents from here is going to be nice, but I'm also thinking about the interface of how we do this. Because
I think we can do it in ingest CLI first.
Yeah, we can do it in ingest CLI first, because I think adding documents is easier than removing them. Because, for example, you have all of those different chunks and they're all broken up, and you might sometimes have, I don't know, 1,000 chunks or 100 chunks. And how do we show users a way to search and find them? So I think it's going to be very, very, very interesting to add this feature. But also open source LLMs, just like mentioned before, we do have a lot of those questions, and most of those questions come from private companies that do take, for whom it's very important to keep the data extremely private, because if you really need to make sure that none of the data gets shared with OpenAI or any other company, this is the only way to do it. And currently Alpaca does provide the answers, but it does need some fine-tuning to make it work. Otherwise it's going to hallucinate a lot. And sometimes it's like, for example, you provided the context and everything, and then you ask it how to cook the fish. It's going to tell you how to cook the fish. It's not going to respond anything relevant to the context that is being provided. And sometimes it's good to make sure that your model is more interactive and engaging, but it's also important to make sure it's strict. So it only answers questions that have an answer in the documentation. And finally, some more features that we have here is some small UI updates that we need to finish. Some errors that people reported, an interesting question about supporting other languages like Golang, Rust, and C++. All it really needs to do is to parse it function and class. So we need to just understand where functions are, where do they start, where do they end, and that's it. From there on, we can easily ingest everything.
Or for the language which doesn't have classes, functions, for there, I guess you need to think of the way for your code that you want to parse, the way to split it basically in the most semantic way, I guess, for the AI to process. And then it should give relatively good answers.
I agree. I like the word in the most semantic way because, I think this is the new stage of programming where you don't really have any other means of improving the quality of your program other than just like speaking to it like you're speaking to a human being. And even in our some pieces of our code is pretty much a prompt, and just making sure this prompt is good. And the same goes for documentation. We need to make sure documentation is good, and then the model is going to work much better. So I updated the page. I included a nice 50% discount that you can use on DocsGPT to purchase the Pro plan. The discount is active today, and all of the viewers can experience the power of GPT-4 if you're interested in it or just supporting the project. That will be very helpful for us as well.
So guys, do you have any questions? We'll probably wait for a minute or two. If there is nothing, I think we'll end.
So launched the Pro version basically just this weekend. and I think we'll be adding more features this week. And those features will be things like I think one of the first features we will end is uploads, which will be uploads, but from websites. So we'll probably allow you guys to ingest data straight from the website. And if you can ingest data straight from the website, I think that will be very convenient. So you can just, paste your link and that's it. You'll be able to ingest. And another feature I think that we'll publish soon, it's a tiny feature. It's a small extension. I already talked to Pavel about it. It's going to be a small widget on the website, like in the corner, where you can just ask one question and it will answer it. Okay, somebody has a question. Zombie Kanapa. Come on. So yeah, we're also really interested in making extensions. And if you heard about DocsGPT plugins, is it possible to use custom trained text-to-speech voice model to link it to your framework? Yeah, absolutely. That would be very reasonable, very possible as well. And would you
So
want
you
this
want
text to? Pavel?
No, finish, Alex.
Okay. I'm just thinking, do you want to use it on a website? Okay, using our platform for analyzing lectures and publications from MIT by Richard Feynman. Informal. So you're using it for physics then? Thailand, yes, absolutely. That's what we're recommending because we're migrated to Docker Compose structure since we included uploads because it needs all of the worker services that run in the background. And I think the more our application matures, the more background services is going to have. And Docker is the way, totally. And even when you're launching extensions, I would still recommend you create a little Docker file and a container for it and launch it from there. But for Zombie Kanapa, so are you looking to use it on a website, or how are you looking to use this text-to-speech
I think
voice?
what he imagines is something that we talked about that Docs, for example, can provide you a summary or a timeline what to say, and you parse it into some TTS, and it basically spits out to you a summary or like sort of a lecture from the PDF.
Interesting. Yeah, that could be a good use case. And would you want to talk to it in voice as well, or would you just want to listen to it in voice? Because I think on most devices right now, you can press a button and it just converts whatever you're typing to, to text anyways. But text to speech is a nice feature, maybe. Maybe it's an extension,
Yeah, but we need to find good open source TTS for it. I've seen two that I liked. I think Kokui it's called, or something like that. Kokuai maybe. And the one from Microsoft, but the one is not released yet. The Valley. But Kokui is hard to launch without complication. Probably need to rent a server for it, but otherwise it should be quite good.
So you want to talk to it as well. So I think if you want to talk to it and get responses back, I would rather make a separate extension for it and just interact with it in this kind of way. Also have Arthur C. Clark comment. Sorry again, but going to copy paste no stop. I see. So I see why it is very useful. It's interesting use case. You know, I haven't been thinking that people would use it to study actually, but I think it's actually very useful for that purpose as well. I think students will like it a lot. So, all right, it's been really great talking to you guys and explaining everything. I think we'll make another stream sometime in the future as well, and maybe do a bit more coding or a bit more anything you want. I'll try to see what kind of responses we get. Maybe you guys have specific thing you want to listen or talk about in future.
Thank you. Thank you for your time. Hope this was helpful to some of you at least. We'll probably upload the stream as a video to our channel. So for somebody who missed it, or if you want to share it with someone, like some part with explanation or rewatch it, we'll keep it on this channel.
Absolutely. And maybe we'll make like small clips of like just like instructions of how to launch it, because I think that is useful, because some guys, I think they will benefit a lot from having those explicit instructions on how to launch the model and everything. All right. Bye, guys.
Goodbye. Thank you.